What is the reciprocity theorem? It states that for a linear bilateral active network having single source, this is important. Always in case of the reciprocity theorem, we have only one source, single source. And in case of the superposition theorem, if you are able to recall, we should have minimum two sources. Is it right? It states that for a linear bilateral active network having a single source, the ratio of voltage V in one mesh to the current I in other mesh is the same when positions of V and I are interchanged. इस यहाँ पे हमें ये theorem का calculations के लिए generally use नहीं करते हैं. We will use this theorem for verification purpose. Is it right? What this theorem says? If here is voltage V and here is the current I, what the theorem says? If we are, this is loop 1, this is loop 2. If this voltage is the voltage of the first loop branch and this is the current, then the ratio of V1, I will assume this is V1 for case 1 and this is I1 for case 1. This ratio of V1 and I1 is the same as that of the ratio when the positions of V and I are interchanged. Means हम इस V को यहाँ पे connect करते हैं और I यहाँ पे measure करते हैं. In that case, I will call it as V2 and I2. ये दोनों ratio same होता है. That verifications we have to do using this particular theorem, which is nothing but the reciprocity theorem. I will read out this theorem once again. It states that for a linear bilateral active network having single source, the ratio of voltage in one mesh, this V is in one mesh, to the current I in other mesh, this current I in other mesh, is the same when positions of V and I are interchanged. Means if we are measuring the current here and we are applying the voltage here, in that case both voltages should be same. That is the meaning of this particular theorem, which is nothing but the reciprocity theorem. Generally this theorem we are not using for any calculation. We will use this theorem for verification purpose. This position change करके हम इसका verification करते हैं. So here I will take the two cases under this category. In one case voltage is here, current we have to calculate here. In the second case I will reverse the positions. Is it right? So here case 1. How is the case 1? This is case 1. Now what we are interested, calculate the current and find out the ratio of V and I. So here for the calculation of the current, what I will do, I will take this current as I1. Now I will take this current as I2. I will take this current as I2. Means in what value I am interested? V upon I2. I am interested in V upon I2 for first case. In the second case, I will give the same names and I will put the V on this side and then we will see the calculation. Is it right? This is plus minus, this is plus minus. Again, in this case, this is plus minus, this is plus minus. Use any method for the calculation of this current time. Use any method. I will use the direct inspection method. I will write here. By direct inspection method, we get. Here is verification. That is nothing but explanation part of this theorem. If we are using the direct inspection method, how is the direct inspection method? Here for two loops, this is Z11, Z12, Z21 and Z22. Similarly, resistance में हम कैसा लिखते हैं? R11, R12, R21 and R22. First, we will find out these two values. What is the impedance of the first loop? Impedance of the first loop is Z1 plus Z2. This value. How is the impedance of the second loop? Z2 plus Z3. This is Z2 plus Z3 is the impedance of the second loop. Now we will find out these two values. Impedance which is common to the both branches Z2, but that value should be minus Z2 and here is minus Z2. What are the currents? Currents are I1 and I2, which is equal to constants. What is the constant for the first loop? If we are traveling in the clockwise direction, this is negative to positive, which is a plus, which is otherwise I will take this source. It should be AC. This should be AC. Here in this case, if we are traveling in this direction, this should be the plus. It's negative to positive because I have taken the impedances. If I have taken the resistances, then this will be the DC. Is right? Otherwise, it will become the problem of the transient response, which is not the part of our syllabus. Now here, in this case, if we are traveling in the clockwise direction, this is a plus V. This is plus V. And how is the second case? It is 0. That's it. Now here, in this case, in what value we are interested? We are interested in this I2. We are interested in this I2. What is the formula for I2? Formula for I2 will be, it is delta 2 divided by delta. Delta 2 divided by delta. First, we will find out the delta. And then delta 2. How is the delta? Delta is nothing but determinant of this term. Determinant of this matrix. How is the determinant of this matrix? Multiplication of these two minus multiplication of these two. Means here, in this case, equation will be Z1 plus Z2 into Z2 plus Z3. This multiplication minus multiplication of these two. This minus into minus, that will be plus, and it will be Z2 square. Is it right? Minus Z2 square. I will simplify this. If I am multiplying by Z1 and Z2, means it is Z1 into Z2. Then Z1 into Z3 means plus, it is Z1 into Z3. Then plus, I will multiply Z2 and Z2, means it is Z2 square. Then Z2 into Z3 means plus, it is Z2 into Z3 minus Z2 square. Is it right? This plus Z2 square will cancel with this minus Z2 square. What is the remaining term? This remaining term is Z1 into Z2 plus Z1 into Z3 plus Z2 into Z3, and this is the delta. How is the delta 2? Delta 2 is nothing but this second column is replaced by the constant. Means this is Z1 plus Z2, this is minus Z2, this is V, and this is 0. Work out this calculation, that will give the delta 2. How is the delta 2? Multiplication of these two minus multiplication of these two. Multiplication of these two is 0, minus, and this minus, that will become plus V into Z2. This is V into Z2, and this is the value of delta 2. Is it right? Means if we are finding this I2, which is equal to V into Z2 divided by V into Z2 divided by this delta is Z1 into Z2 plus Z1 into Z3 plus Z2 into Z3. This value. This explanation is the lengthy part. That's it. This theorem is not difficult. If we have this, in what value we are interested? We are interested in the calculation of ratio of V and I. If we are shifting this I on this side and everything on the other side, if this I on the one side and this V I am keeping on that side, means V upon I2. Now look at carefully. इस V को यहाँ पे ही रखा, इस IT को इधर लेगा, बाकी सभी terms इस side पे. So how will be the equation? Z1 into Z2 plus Z1 into Z3 plus Z2 into Z3 divided by Z2 will be the ratio of V and I in first case. This is the equation number 1. This is the equation number 1. Similar case we will do by shifting the source here and current here, and we will repeat the same procedure. Is it right? Now I will use the case 2. I will use the case 2. Now look at how is the case 2. For case 2, I will write here case 2. Case 2. Now we will change the positions of V and I. Now we will change, otherwise I will write here. Now we will change positions of V and I. V and I. I will draw the figure. How is the figure? Look at carefully. Its figure will be something like this. I am calculating the current here right now. This is the current in which I am interested. Is it right? This will be the impedance. This will be the impedance. This impedance will be the same. This impedance will be the same. This is the impedance again same. Just I'm taking this V towards this. This is V. इसका पोलैरिटी कैसे था? ऊपर था, ऊपर ही रखना है पोलैरिटी. ये Z3 है. Is it right? This is Z2. This is Z1. Now इसका डायरेक्शन किस तरफ था? डाउनवर्ड. इसका डायरेक्शन भी सेम रहेगा, डाउनवर्ड. Is it right? Otherwise, you can take the actual value, because when we have a single source in the circuit, we can find out its actual value. We can find out its actual value also. Now, इस केस में क्या होगा? In this case, now I will name this current. ये actual current हमें पता है. I will take this value as actual, which is nothing but I1 dash, and this value in this case is I2 dash for the case 2. We will take the currents of the case 2 as I1 dash and I2 dash. Okay, by direct inspection method. What we want to show here? We want to show this equation is 1 is very same as equation number 2. That I am trying to show. This here we are interested in this current I1 dash. We are interested in I1 dash. This current in this path, this position. Is it right? Now I will write here by direct inspection method we get. By direct inspection method we get. Not what we get from the direct inspection method. I will prepare this matrix. I will prepare this matrix. These are the currents, which is equal to the constants. Is it right? How is the direct inspection method? Z11, Z12, Z21 and Z22. First we will find out this Z11 impedance of the first loop. The same value again. Z1 plus Z2. This value Z2 to impedance of the second loop. Impedance of the second loop Z2 plus Z3. This value Z12 and Z21. Impedance which is common to the both, which is Z2. But this value should be minus. This is minus Z2. In this case, how is the current? Current is I1 dash. What is this current? This current, loop to current, is I2 dash. What is the constant in the first loop? If we are traveling in the direction of the current, there is no source. Constant is 0. For the loop 2, if we are traveling in the direction of the current, negative to positive plus V. V is the value. Is it right? In what value we are interested? We are interested in the calculation of I1 dash, which is equal. ये value हमें चाहिए. What is the formula for I1 dash? I1 dash is nothing but delta 1 upon delta. First, I will find out the delta. How is the delta? This value, the delta, is multiplication of these two minus this. This here, in this case, Z1 plus Z2 into Z2 plus Z3 minus, and this minus into minus will be plus, that is Z2 square. If I am simplifying this equation, I will get the same terms, because look at this delta, Z1 plus Z2 into Z2 plus Z3, which is very same as this. This is very same as this value. ये value और ये value same है. A equation. That's why I will write this final equation directly. Otherwise, we will simplify it. It will be Z1 into Z2 plus Z1 into Z3, then minus, plus Z2 square, then Z2 into Z3 minus Z2 square. This square term will cancel with this minus term. This final value will be Z1 into Z2 plus Z1 into Z3 plus Z2 into Z3 is the delta for this case. Now we are interested in the calculation of delta 1. How is the delta 1? This first column will be replaced by the constant terms. What are the constant terms? 0 and V. And this value will be minus Z2, and this is Z2 plus Z3. This value. How is the case? Multiplication of these two minus multiplication of this multiplication will be 0 minus, and this minus will be plus, means Z2 into V will be delta 1. Therefore, this is Z2 into V or V into Z2 divided by this value Z1 into Z2 plus Z1 into Z3 plus Z2 into Z3 will be this value. if we are finding this V ratio of this V and I, means if I am putting this V on the same side and I'm shifting this value, this V divided by it is I1 dash, which is equal to V divided by I1 dash, which is nothing but Z1 into Z2 plus Z1 into Z3 plus Z2 into Z3 divided by Z2. And this is the equation number 2. Now look at the equation number 1 and look at the equation number 2. If we are comparing the equation number 1 and 2, look at here. This is the voltage, ratio of voltage and current. Sorry, this is the ratio of the voltage and current. When voltage source is here and current source is, current we are calculating here, that ratio is something like this. And if we have changed the positions of V and I again, the ratio will be the same. This here, look at this Z1, Z2, Z1, Z2, Z1, Z3, Z1, Z3, Z2, Z3, Z2, Z3 divided by Z2. This is V upon I1 dash and this is V upon I2. Means what this theorem says, circuit having the single source, I will show that theorem and then we will proceed further with such kind of the thing. So here in this case, it says that for linear bilateral active network consisting of the single source, the ratio of voltage V in one mesh to the current I in other mesh is the same when the positions of V and I are interchanged. Means whenever we are changing the positions of V and I, its ratio will be the same. This is the ratio for first case. This is the ratio for first case, which is as per the equation number 1. This is as per the equation number 1 and this is as per the equation number 2. That is the statement and explanation of this theorem, which is nothing but the reciprocity theorem.